This is Unit 6-4 for 7th grade. We're talking about tree diagrams and list combinations. So we've done a lot of probability, and one of the things that we're going to do along with probability is creating a tree diagram so we can see all of our options. Taking a look at example 1, I'm just going to kind of go through and explain this along with example 2. So it says the coin below is flipped. There's an equal chance of heads or tails, something we've talked about a lot. The second time it is flipped, there's an equal chance again of heads or tails, and so forth for how many times you flip the coin. So here's what I want to show you guys real quick. Here's our little coin. Sorry, my version of it's really crummy. We have a 1 in 2 chance of flipping heads. We got a 1 in 2 chance of flipping tails. Every time we do that, we have a 1 in 2 chance of getting one or the other. Again, pardon that we have such a crummy version of this. So what we've talked about doing is every time, like if I wanted to flip a heads 3 times in a row, we would do 1/2 times 1/2 times 1/2. And what I want you guys to see about that is if I do that, I've got 1/2 times 1/2 times 1/2. Multiplying straight across, I get 1 on the top, and 2 times 2 is 4, times 2 more is going to be 8. So we have a 1 in 8 chance of getting heads 3 times in a row. So here's where I'm going to change colors, and I want you guys to see something. I want you to see the total number of options. So going this way, we heads, heads, and heads. We're saying that we have 1 in 8 chances, but we haven't really talked about what those other 8 possibilities are. Well, they're all lined up for us here just across the bottom. And I'm just going to keep following that same tree. I could get heads. Hang on, let me change colors on that. I could get heads. I could get heads again. Then I could get tails. Or I could get heads, and then I could get tails, and then heads. Or, still following the same line, I could get heads, going down to tails, and then tails. And that's just 4 other options. And if you look, I've got 4 total options. I've got, I don't have another color to go with, so we're just going to stick with blue for right now. I have 1, 2, 3, 4 options on the left side. And on the other side, I have another 4 options. So our original problem is we were trying to flip heads 3 times in a row. And we said that we had a 1 in 8 chance of doing it because we did a 1/2 times a 1/2 times a 1/2. Well, I want you to see with this line, those are all 8 options. And we only had 1 that would give us heads. So that was our 1 in 8 chance. The point of the tree diagram is to represent every single possibility that we have. Another way of doing this is we could talk about, we have 3 coin flips that we are going to do. And we know that we want to get heads every single time. So we're hoping that we have heads, heads, and then heads. Well, I can just talk about how many all of my options that I have and multiply them. Well, on my first flip, I have 2 options. On my second flip, I only have 2 options. On my third flip, I only have 2 options. So if I multiply straight across, I still get 8. I have 8 total options that I could possibly come up with, but only one of them would be heads, heads, and then heads again. Taking a look at example 2. So this is the same coin toss, but arranged sideways. A tree diagram can be written bottom or left to right. So all that to say is this one's going straight up and down, which is easy enough. This one is going side to side. So it's the exact same sets of combinations. Something else that this diagram does that I actually like a lot more, it lists all of the possible outcomes so you don't have to follow the line. There's our heads, 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 tails, heads, tails, heads, heads, tails, tails, and then pretty much the exact same combination, but all of these start off with tails instead. So good, just to kind of look through those, take a minute, take a look at it, think of every combination that you can come up with just off the top of your head and see where that combination falls on the tree diagram. Now for exercise 1, it says create a tree diagram for flipping a coin and then rolling a fair-sided number cube, so just a die. So with our coin, we've got 2 options. We can get either heads or we can get tails. If we roll a number cube, well, there are 6 different options. We've got 1, 2, 3, 4, 5, and 6. Those are all of our options. So to create this tree diagram, we've got 2 different ways to do it. My recommendation is always go with whatever way or whatever order they say it. They say the coin, then rolling the number cube. So this is going to be, I'm going to do this one sideways. So here's my first flip. I'm either going to get heads or I'm going to get tails. I don't do any more flips after that. Let's say, so here's my first flip. Let's say I got heads this first time. Well, now I've got to roll my number cube. Well, if I roll my number cube, I'm either going to get a 1, or I'm going to get a 2, a 3, a 4, a 5, or a 6. But let's say I didn't get heads. So instead, maybe on my first flip, I got tails. Well, now my other thing is I still have to flip or I have to roll the die. So I could still get a 1, a 2, 3, 4, a 5, or quite possibly a 6. Now I want you to see how many options that we have. I want to list all of these out. So I'm going to follow the tree diagram, and I'm going to do this in green. So let's say I flipped a coin and got heads. So I'd have heads and then a 1. So that's heads and 1. Let's say I went the other way. Let's say I flipped my coin and I got heads and then got a 2. So I'd have heads and 2. Next option would be, let's say I flipped a heads, got 3. I think you already probably see where this is going. So what I'm going to do is I'm going to go and keep going in black on this one. So I've got heads, I could get 4. If I flipped heads, I could get a 5. If I flipped heads, I could roll a 6. Now on the other side, let's say I'm doing tails. So I flipped tails and I got 1. So I have tails 1, tails 2, tails 3, tails 4, tails 5, and tails 6. So this is every possibility that I have. I want to show you 2 more things before I get done. I've got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12 options. That would take a long time to go count on every single one of those, especially on tree diagrams that get a lot bigger. Or I could have just counted, well, I got 1, 2, 3, 4, 5, 6, 1, 2, 3, 4, 5, 6. So obviously that's 12 both times. Or we did 2 things. 2 different events happen. I can multiply the numbers of those 2 events. With the coin, I've only got 2 options. With the number cube, I've got 6 options. When I do 2 times 6, I get 12 total options. Now, could I compare these two? I know that I have 12 total options. Let's say I wanted to find the probability of flipping a heads and then rolling a 1. Well, there's only one of those right there. That would be a 1 in 12 chance of that happening. Any single one of these options right here, because they're the only one of their kind, would be a 1 in 12 chance of happening. Alright, on the back side of this thing, exercise 2 is actually what we just did. It says list the following combinations from the previous tree diagram. Well, we already did that, so I'm not going to worry about that. That part's done. Exercise 3 says list the combinations for the following situation. Garrett has to wear a uniform to school. He has 3 pairs of pants, khaki, navy, and black, 4 polos, red, yellow, green, and purple, 2 jackets, jean, and leather. You can use the first letter of each color. So we're supposed to list the combinations, kind of like what we did on the previous page with H1, H2, H3, H4. I want to do all of them on this just because I want you to see it. So we're going to do the tree diagram, we're going to list them out, and we're just going to let's find out how many combinations first, because that's pretty easy. So we've got, looks like he's got to find pants, he's got to find a polo, and he's got to find a jacket. Let's see how many combinations. For pants, he has 3 options. So we've got 3 different things that we're finding, right? So he's got 3 pairs of pants, he's got 4 polos, and he's got 2 jackets to choose from. Well, let's multiply this straight across. 3 times 4 is 12, times 2 is 24. When I create my tree diagram or when I start making my list, I should see a total of 24 combinations. Let's start with the pants first, okay? So here's my starting point. I have 3 pairs of pants to pick from. I can either have my khakis, my navies, or my black ones. From each pair of pants, I have 4 different shirts to consider. So from the khakis, I could wear red, I could wear that yellow polo, green, or I could wear, I think it was navy, I can't see it on mine, oh, I'm sorry, purple. So khaki pants, he could wear a red, yellow, green, or purple shirt. Well, he has that same option with the navy pants. I'm going to change colors in this so it doesn't start blending together too much. With the navy pants, I could wear red, I could wear the yellow, I could wear the green, or I could wear the purple. But the same thing is true with the blue pants. I could wear a red shirt, yellow shirt, green shirt, or a purple shirt. But there's also the choice of the jacket. So let's say I pick the khaki pants, decide to wear the red shirt, but now I want to wear what was the jacket? What were the two jackets? Jean and leather. I could either wear the jean jacket or I could wear the leather jacket. And that's going to be true on every one of these. I could wear the jean jacket, leather jacket. Change colors again. Jean jacket, leather jacket. Same thing here. Jean jacket, leather jacket. But then I still have all of those other options right down here. So I'm gonna, man, my colors are starting to blend together. I'm sorry if yours is getting way too big on this. So jean jacket, leather jacket, jean jacket, leather jacket, jean jacket, leather jacket, jean jacket, leather jacket. And finally on here we've got jean jacket, leather jacket, jean jacket, leather jacket. Probably getting tired of me saying this because I know I am. Jean jacket, leather jacket, and jean jacket, leather jacket. So there's our tree diagram. And again, we should have a total of 24 options. If I went through and counted every leather jacket on the outside, I should have a total of 24. But now I get to do the fun part of listing every stinking option. So I'm going to kind of follow along the diagram, and I'm going to do them all in the same order. Excuse me, my voice keeps cracking. Do them all in the same order. So I'm going to do khaki, red, jean. K, R, J. Then I could do khaki, red, leather. Okay, so now that's this side done. Now I'm going to do khaki, yellow, jean, khaki, yellow, leather. So that's yellow shirt done. Yellow shirt. Now khaki, green, jean, or whatever it was. Khaki, green, leather. Khaki, purple, and jean. A little bit. Khaki, purple, and leather. So at this point, I should have a total of 8 options. Here's why I should only have 8 options. I've only done this for the khaki pants. Well, I've still got the navy and the black pants. So that would be 8 each, because 8 times 3 is a total of 24 combinations. So let's make sure I got my 8 first. So there's 1, 2, 3, 4, 5, 6, 7, and 8. So looking good. I'm going to do the exact same list with the navy pants and with the black pants. So if I start doing my next combination with navy, then I would have red, and I would have jean. I want you to see that that starts out the exact same list as this part, because if I kept going, it would be navy, red, and then leather. And I'm talking about going through this thing right here. Let me change colors. Through navy, red, jean, navy, red, and leather. So the combinations are going to match almost exactly. Well, actually, they are going to match exactly with what's over here on this side. So that's what it's going to look like with navy, and now I'm going to show you with black too. So again, these look almost the exact same. Like this whole section, that whole section, and that whole section are identical for each pair of pants. And we have our total of 24 options listed out there. All right, this is going to be the homework section for the tree diagrams and list combination practice. I'm going to change this up a little bit as I go. Just because some of these are a little too long, and no lie, it was late Friday evening when I started making this, and I might have been a little delirious, so some of these problems are a little strange. All right, so number 1, it says, draw a tree diagram to best represent all possible outcomes of rolling a number cube numbered 1 through 6 and list all combinations. So here's our number cube. So number cube is just 1 through 6. If I'm going to make one roll, oops, hang on, there we go. My one roll, I've got 1, 2, 3, 4, 5, 6 options that could happen from that one roll. I could get a 1, I could get a 2, I could get a 3, I could get a 4, I could get a 5, or I could get a 6. That's our tree diagram. This is for a single roll. That single roll, this is the roll right here. And then these are all of the options that could happen from it. So now I'm going to list all those out. Well, I already kind of did it, but my first option, I could get a 1, I could get a 2, a 3, a 4, a 5, or a 6. Sorry, that one's off by itself. Didn't mean to make it feel lonely. But that's pretty much all there is to number 1. Some of these get a little more complicated, so sorry. So number 2, draw a tree diagram of flipping a coin 5 times in a row and list the combinations. I want to change this one up. 5, I'll be honest, it's going to make it too big. We're going to change this to 4 times. So, first flip. Let's go and talk about that one. My first flip, I have the options of getting either heads or I could get tails. That's one flip. We got 3 more flips to go. So if I flipped heads the first time, I could get heads or tails the second time. Same thing over here. I could get either heads or I could get tails. So that's twice in a row. So let's say I flipped it again. Here I could get heads or I could get tails. Here I could get heads or I could get tails. Here I could get heads or tails. And here I could also get heads or tails. Alright, so that's a total of 3 options. You still got to come up with the 4th one. So guess what? Here I could get heads. Here I could get tails. Same thing here. Heads, tails. Same thing here. Heads, tails. Same thing here. Heads, tails. Now, this last part, you guys are going to finish that up because that shouldn't be too bad. But I want you to consider how many total combinations that we've got here. So I could get heads 4 times in a row. I could get there, 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 and then there. So if I got that 4 times in a row, well, my first part of my list would be heads, 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 heads. Well, let's say I didn't get that from my list. So it would be heads, 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 and tails. So that would take care of that one. To get to that next one, it would be heads, heads, tails, heads. So that takes care of that one. And pretty much what I'm doing is I'm going down the list of every possible option. So heads, heads, tails, tails. That takes care of that one. For the next one, I've got heads. Oh, where am I at? Oh, yep. Here we go. Tails, heads, heads. So that's done. Heads, tails, heads, tails. That takes care of that one. And I'm just going to finish up this part of the tree. So, just so you guys can see what I'm doing, because I want to make sure you're following me. First flip could be heads, then tails, then I could get tails, and then I could get heads. So that part is heads, tails, tails, heads. Final one on this part of the tree diagram, heads, tails, tails, tails. So that would be heads, tails, tails, tails. That's all of the options that I've got for flipping heads first. So now the next set of options would be flipping tails first. So you'll list all of those out. And there should be another list here that starts with tails each time. And it should match this whole section right there. Actually highlight that a little bit better so you guys can see it. That side should match on the other side with just tails. So just a reminder, things that you need to finish up on your own. You need to finish listing off this side for heads and tails. And you need to finish listing off the whole tail side over here. It's going to match the head side on the other one. Alright, number 3. Steve has shirts that are striped, pink, green, and blue. He also has pants that are black, red, and puce. He'll either wear a watch or a necklace of teeth. Create a tree diagram of his options and list them out. First, the only thing I'm going to really help you out on this one, okay? He's got 1, 2, 3 options for his shirts. So, first option is shirts. Second options are pants. Well, he's got black, red, and puce. That's another 3 options. And then for his third thing that he's got, he's either going to have the watch or, well, the teeth. So, 2 options on that one. There should be a total of 18 options. So there should be 18 things at the end of your tree diagram, and you should have 18 things on your list when you are finished with that one. And again, I would just use initials. I would not expect you to write all of that out because that would take way too dang long. Number 4 on the back side. It says Jim is trying to decide what to eat. His drink choices are Sprite, Mountain Dew, and crab juice. His lunch choices are burger, pizza, and cockroach entrails. For dessert, he can have ice cream or fried toenails. Create a tree diagram for his options and list them out. So I'm going to go ahead and simplify this one for you a little bit. Like I said, I was a little delirious when I was making this one, and some of these options are a little bit gross. So just to limit how much we actually have to write out for our lunch choices, we're going to get rid of, like, I'm sorry, that's just gross. We're going to get rid of pizza on that because pizza's gross. That will limit how large our tree diagram is. So now we're going to think about how many options we've got. He's got drink choices, he's got lunch, and he's also got dessert. He's got 3 drink choices, he's got 2 lunch choices, and he's got 2 dessert choices. If I multiply these, it will tell me how many total options we've got. So 3 times 2 is 6, times 2 more is going to be 12. So we should expect to see a total of 12 items in our tree diagram and 12 things listed out. I'm going to help you out a little bit with this tree diagram. His first choice that he has to make is he's got to decide between Sprite, Mountain Dew, and crab juice. So we've got Sprite, Mountain Dew, crab juice. Lunch choices, this is why I simplified it a little bit because this branches out real fast. We've got burger and cockroach entrails. So from here, I'm going to go ahead and change colors for this part. We could either have a burger or we could have ourselves a nice crunchy cockroach. Same thing here. Burger, cockroach. I think the choice is pretty obvious there. From here, burger or a cockroach. Now, we've got our dessert to choose from. We've got ice cream and fried toenails. So we're going to label that just I, and we'll go with T. So if I went with a burger, I could have ice cream, or I could have toenails. Same thing here. Ice cream, toenails. Sorry, my I's and my T's are not very different. All right, so we got I, T. Same thing here. I, T. And finally, I and T, I, T. So like I said, just so you guys can see this real quick, I've got 1, 2, whoops, use the highlighter in that. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12 options. Now we got to create the list. I do want you guys to make your own list. You'll have, let me trace this with the highlighter real quick just so I can go through. Okay, I'm going to kind of say them for you, but you have to list them out. SBI, SBT, SCI, SCT, MBI, MBT, MCI, MCT, CBI, CBT, CCI, CCT. I mean, those are all of your options. I just want you guys to see how to write that, or how to follow the tree diagram. So you start off with SBI, and then you guys are going to list all those other ones out on your own for that part. Should be only 12, so that one won't be too bad. Final one, I'm going to read it, and then I hadn't decided yet. I think I'm probably going to leave you alone on this one. It says, Dorcas and Dingus are playing a game. They toss a fair 6-sided number cube numbered 1 through 6, and they spin a spinner, which is divided into 3 equal regions. 1 colored red, 1 colored green, and 1 colored blue. Create a list of possible outcomes as well as a tree diagram. So again, let's talk about our total number of options. First, we're going to roll the die. Well, on that die, we have 6 options. Then we are going to spin a spinner, which gives us 3 options. So I multiply these to see how large of a doohickey that we're going to be talking about. They're going to be a total of 18 options when I get finished. So you're going to have your spinner first. I'm sorry, no, the number cube first. You have your 1, 2, 3, 4, 5, and 6 on it. So 1, 2, 3, 4, 5, and 6. From there, you're going to have your 3 color options on each one. So from here, what were our colors? We had red, green, and blue. So R, G, and B. You guys will need to finish filling out the tree diagram, and you will need to make your own list for this part. If you have any questions, please come ask.